Hi, this is Mrs. Kidman, and in this video, we are going to talk about how we can solve the system of equations by substitution. Now, what substitution means is if we have something that's equal to it, we can put it in its place. Now, a lot of the time, people will see substitution as they get something like y equals 3x squared plus 7x plus 2, and x equals 3. And then they take this x equals 3 and put it in, substitute it in everywhere for x. That's one example of what we see. When we have equations, the beautiful thing is notice how both of these equations are equal to y. So when they have a system of equations that's equal, what we can do is if they're both equal to y, that means they're equal to one another. So solving by substitution means I'm going to set my two equations equal to one another if they're both equal to y. So let's do that. X squared plus x minus 1 equals negative 2x plus 3. Now, I just want to solve this like I always solve equations. So what I'm going to do here is instead of leaving it like this, I'm going to move everything to the left and make it equal to 0. So I'm going to add 2x to both sides. I'm going to subtract 3. And I end up getting x squared plus 3x minus 4 equals 0. Fantastic. Then what we want to do is we want to solve this for our x values. Now remember, solutions are going to be xy pairs, but we can find those x values and then take our x values, plug them back into our equation to get the y values. So I'm going to solve this one by factoring. So I want two numbers that multiply to negative 4 and add to 3. Well, that's going to be 4 and negative 1. So this becomes x plus 4 times x minus 1 equals 0, which means x equals negative 4 and x equals 1. So those are going to be my two x values here, negative 4 and 1. Now I want to find my y values. To find those y values, I'm going to take my x values and plug them back into one of these equations. I'm going to plug them into my linear equation because the math is simpler. It doesn't matter which one you plug it into, we will still get the same y values out. So our y value when x is negative 4, I'm going to put negative 4 in everywhere there's an x, is going to be 8 plus 3, which is 11. So negative 4, 11. Our other point is y equals negative 2 times 1 plus 3. Again, we're going to take this x value and plug it in to find our y value, and that becomes negative 2 plus 3, or y equals 1. And this is our solution to our system of equations. So again, when we solve by substitution, if they're both equal to y, we're going to set them equal to each other, move everything to one side so it's equal to 0, and then we're going to solve it. Sometimes it'll work out well to factor it. Sometimes we might have to use the complete the square method or something like that, but that will be evaluated after we move everything to one side. So let's take a look at this next example here. Let's solve this one right here by substitution. So again, these are equal to one another. So we can either, so we want to plug everywhere that there's a y. Do you see how these all equal y? That means I can set all of these equal to each other. So that means my solution to my system of equations here, it can be when x squared plus 9 equals 9. Well, let's solve for x squared. That's when x squared equals 0. So we can square root both sides and x equals 0, because remember the square root of 0 is just 0. So then if I want to solve my system of equations, that means that my y value, well here it says y has to be 9. I could also plug 0 in here and get 0 squared plus 9, and that would give me 9 as well. So my solution here is going to be 0, 9. Now, I want you to try this next one on your own. So again, we're going to set the two equations equal to each other and then solve for x. So go ahead and pause the video, work out this problem. When you finish working out this problem, unpause the video and we'll go over it together. Okay, hopefully you've had a chance to run through this problem on your own. So again, we're going to set each equation equal to one another. So I set them equal to each other and I moved everything to one side. So I got x squared plus 2x minus 3. Now after I've done this, I went ahead and I chose to factor this, and I factored it into 3 and negative 1. Because 3 times negative 1 equals negative 3, but 3 plus negative 1 equals 2. So then that became x plus 3 times x minus 1 equals 0, and that means that x equals negative 3 and x equals 1. So those are our two x values there, negative 3 and 1. So then with that, we want to take those and plug them in up here. So as I plug negative 3 into this first equation, I end up getting 15. And as I plug 1 into my first equation, I end up getting -5. Now remember that these 2 points need to be plugged back into one of these two equations, not into this equation. If we plug it back into this one right here, we're just going to get 0 out because that's how we got it. We need to make sure that we plug it back into one of our two original equations. Now let's run through this last one all together. So again, what we're going to do is set them equal to each other. So -3x squared plus 2x plus 1 equals 5 minus 3x. We want to move everything to the same side, so I'm going to subtract 5 from both sides, add 3x to both sides, and we end up getting -3x squared plus 5x minus 4 equals 0. Now, I could try to factor this if I wanted to. In this case, I'm going to use the quadratic formula to solve for x here. Again, any method will work depending on what your numbers are. So my a value is -3, b is 5, c is -4. Then we want to do that discriminant. So 5 squared minus 4 times -3 times -4. Well, this is going to be 25. 4 times -3 is going to be -12, and that times 4 is going to be 48. So minus 48, and 25 minus 48 is going to give us a -23. Now we have two options here. In this case, when we're solving, what this means when we get a negative discriminant is that when we graph these, we're going to have one that looks like this and one that looks like this. They're not going to ever cross each other. Now we could find where they would cross in the imaginary plane, but that doesn't really help us. So we recognize that this is going to be our discriminant, and we can say that there are no real solutions to this set. And we want to make, and we only care about real solutions when it comes to solving systems of equations, because we want to know, do they cross? Do they intersect? If they don't intersect, although they might in the imaginary, in the complex plane, what I care about is, do they intersect in the real plane? So that is how we would solve systems of linear equations by substitution. Please check out the previous video on how we do it by graphing. And if you're interested in how we can do it using elimination, please check out our next video. Thanks.